Every single person in that CapEx chart has to come to SpaceX to get its business done. We are absolutely categorically slamming into a compute demand curve, supply gap. We are in a weird world, people. Orbital data centers are absolutely required because we can't get enough compute on planet Earth. And for the first time, I'm programming in a new programming language. I have spent 30-something years getting to a point where I can build this app on my own. Starlink is going to revolutionize the way we think about access to compute. We're about to transition into what will be an explosion of these things.
Unsupervised robotaxis are operating on the highways.
People are not ready for that from a market perspective.
How far we are away in terms of being able to give the car instructions like that? Hey, Phil, how are you doing?
Doing well.
It's been 2 weeks. What's going on?
It's 2 weeks. June already? Oh my gosh.
I hear you've been busy.
I've been busy. What's coming up in a couple of days?
Yeah, exactly. Well, you've also been working on something fun that we're going to actually do a live demo of.
Yeah, we'll see how live demo goes.
Yeah, exactly. So that should be fun. But before we get there, we'll cover a couple of items and then we'll go into that. That'll be something different, I think. Obviously, we're going to talk a little bit about Tesla and SpaceX. And today I decided to swap the shirts. I put the SpaceX shirt on. I gave you the lowly Tesla shirt. I'm sorry about that.
You mean I've got the terrestrial-based shirt.
Yes.
Yeah.
I feel that with my lack of hair, that maybe the space theme is better for me.
It's true, maybe. Although I do have my Starlink shirt on, so I just want to point that out.
You do. You've made up for it in real life.
However, on the other hand, loving my Tesla FSD recently, trying to build a streak.
How many miles are you up to?
I only got up to, I was busy with stuff. I only got up to 20.
Yeah.
So
I've downloaded it. I have not had a chance to check it out yet. That's how busy I've been. No reason to drive anywhere.
I was telling my wife this morning, why don't you she had to go up to the city, which is give or take 60 miles from South San Jose where I live. And so why don't you take the Tesla, build a new streak? She's like, you're nuts. Like she loves the Tesla, but I mean, just fabricating a reason.
That's right.
Yeah.
Well, we have some news.
I think we do. Yeah.
Yeah. So Ashok says unsupervised robotaxi now available in the greater Austin area. And so, as you said, Robotaxi, the way it was intended, starts in earnest today in Austin.
Yeah, I mean, I think I was maybe overselling it, but I mean, what's going on here is that we're about to transition into what will be an explosion of these things, and it's going to hit everybody like a ton of bricks because we're almost rounding a year on their start, and I think people have written it off.
Yes.
It's never going to happen. No bullshit. It's going to happen, man. I mean, it's going to happen. I mean, how do I know that? Well, driving in my Tesla today, 1433, I mean, honestly, problem solved, folks. I don't even bother looking at the road much at all. I trust the thing very much so. I think it's just we've talked about this before. I think if we break the class of problem into safety and operational, I think safety box is largely checked. I mean, not completely checked, but but where we are probably is in the operational, weeds, because this is where it's very, very difficult to make this device completely robotically able to figure out exactly where to pick up, drop off, navigate correctly, situationally, when there's really nobody to supervise. I mean, in our cars, we do a lot more supervision than we think, to be honest, because we kind of like when we start the route, we're like, we pick a different route. We do things that we're not aware of, that we're supervising the ride. Now you get yourself in a robotaxi that, as a customer, it's got to operate very smoothly.
There's also a lot of things too. I find as a passenger or even as a supervisor with FSD, there's a lot of preference items that I drive in a certain way, rightly or wrongly.
Right.
Behave in a certain way, and that's what I prefer. But that's not necessarily the best way to do it. That's just my preferred way, right or wrong.
Right. And it wouldn't, yeah, I mean, while Robotaxi, I think, is dialed in to standard mode, if I'm correct. Operationally, because we have hurry above that, above standard, we have hurry and Mad Max. And it's funny because I think I've always been a fairly aggressive driver, always had performance cars, but sometimes Mad Max is too much. I was taking a mountain road yesterday, testing this app will show, and looking for areas that have, in South San Jose, that have no connectivity. And believe me, there are areas. We think we're in the heart of Silicon Valley. I am, but back on Metcalf Road, there isn't a lot. And I had it in Mad Max mode, and I was like, no, I think we better bring it down. And honestly, I don't really pay attention to it. I trust it very much. I really do.
Yeah.
And all of a sudden, I had a very hard brake situation, and I was looking down at the app, to be fair, and it was on a curve, and I'm like, what happened here? And I looked up, and what did I see? A bird had come across my path. And it's a funny one because and it did also a fairly hard brake for a snake on the road.
Wow.
Which I thought was interesting. But the bird one was a little interesting because, the vehicle isn't really going to hit the bird, right? It just all of a sudden stuns the, so they probably got to tune that a little bit. But I'm telling you, it's so darn good. But you are right. There are I think the in-vehicle robotaxi experience will really, really be nailed once they get that full Grok voice experience integrated, because then you'll be able to, the customer will be able to say, hey, could you, instead of, can you get off the highway here? I don't, they think, look, they're the one paying. They think there's a traffic jam ahead. Maybe there isn't. Maybe it's a 2-minute delay and they want to go off the highway and take a 5-minute delay. But so they're the customer, so let them decide, or that classic thing when you're talking, think about all the times you talk to the Uber driver. I mean, beyond small talk, forced or unforced,
right,
talking about directional stuff.
Yeah.
Where you're like, could you drop me off at, don't door 6 United, go to door 9. Or my house isn't here, it's 300 feet, whatever. So yeah, there's a lot to do there, but this is really, we're getting so darn close, aren't we?
I think so. Any idea on how far we are away in terms of being able to give the car instructions like that?
This is a really interesting topic because what I don't know about voice integration is how much processing power that needs. So right now, if you're using Grok in the vehicle, all you're doing is remoting that to the cloud. Mm-hmm. So all the Grok inference, the voice recognition outside basic wake word stuff, voice recognition, the AI itself, and the, basically the speech to text, which becomes the prompt, the playing of that prompt through the AI, and then the text back to speech, when Rex talks to you in the car or whatever, all that is being done in the cloud. And you can't really do that reliably for a robotaxi service because you don't necessarily have connectivity at all times. So you couldn't rely on it. Yep. So you have to basically move a subset of that total package into vehicle. And then the question becomes, if you're going to do that, how much processing power do you need in vehicle? Because what they can't do is they can't suffer any cycles on the FSD to run this. Imagine voice is heavy, voice recognition is heavy or something. They can't dial down their 36 frames a second or whatever. So it may be that the answer to your question is that integration doesn't happen until robotaxi vehicles, whether they're cybercabs or Model Ys, get AI5 chip.
That would be the moment for sure where the hardware is capable. Is that right? There's no issues with them.
Yeah, no. I think No, I think the hardware is fully capable at that time.
Yeah.
But until that time, I have questions.
If you were to give it odds that it would be capable on AI4, what odds would you give it?
20%.
Yeah.
Yeah, because I just feel like job number one is to service compute cycles for the FSD.
Yeah.
And slipping that in is a tricky act. And but I don't know. Like, I don't know. That's why I'm glad you said give me odds, because it's as if, I don't know whether it's going to be red or black at the casino. So
yeah,
I know what the odds could be. So yeah, that's what I guess.
I just wanted to know whether I should set my expectations high or low, but I think you've helped me probably calibrate that.
I would go low, because unless it's a very tough thing. I mean, I've been at these decision points in engineering as well. It's like, do I rely on the cloud? Do I not rely on the cloud? If you map that entire green space there, my guess is you could rely on the cloud for the entirety of that green space. But if you go outside that green space between, say, Austin and San Antonio, or somewhere else, I mean, the good news is that maybe they would say, okay, cloud-based system is a good first run at this, and could provide some kind of service. The voice service isn't available at this moment.
Yeah.
I mean, that's possible if you consider dense city locations. I think that's,
I feel sorry for the person that lives in this area indentation here on the left side. Looks like a little ear. Everybody almost around him has access to the service, and this one doesn't yet.
Do you know what's there?
I don't. I should research that and find out. I
mean, there's a reason.
Yeah. It might be some geographic thing. I'm not sure exactly.
I suspect that every single route, every single mile of highway or street in that green, what are you going to call it? Polygon? I don't know what this is. In the green shaped object has been run over by Tesla autonomous systems many times.
I would think so.
Yeah, I think, as I've said in previous podcasts, that what I think they do through that whole validation step, and what they do actually through the operational portions of this, is that they're collecting this data here, and they can run down, they can easily traverse. They can build a traversal system that traverses every single segment of roadway, highway, city, every possible or intersection decision point. So take 5th, turn left at Main Street. Take 5th, turn right at Main Street. Take 5th, go straight at. I think they can traverse all that hundreds of times and get a good sense. Now, what they won't get a good sense of is, situationally things are different. One day it's raining, another time they're doing it at night, another time there's a person walking through the intersection illegally. Another time there's a puddle, another time there's a duck in the road. But from a graph of the roadway itself and its configuration, beyond, say, construction changes, I think they probably have it covered.
The other thing they have to be worried about is Waymos that are in the wrong spot. That's a whole other issue. The one thing we did hear today, Phil, on this is that the unsupervised robotaxis are operating on the highways within this geofenced area.
Yeah. Yeah, it's funny because I think that Tesla's always worried about that, because it's the speed that's the problem here. It's really, they worry that a highway collision is much greater chance of it being a serious injury or fatality than.
It's a much higher consequence for sure than just a bender. Yeah.
But it's ironic too, because in many ways on a major highway, divided highway, 3 lanes this way, with FSD, it seems to me that the incident rate of those types of things would be fairly low.
Yeah. I actually feel more confident in the car when it is on the highway.
Yeah, I know. That's kind of what I meant by it's sort of ironic because, if you use speed as the tell, I'm sure they have the data.
Yeah.
Like the other side of this is that you don't need to go and look at a bunch of, let me put it this way. Tesla never needs to go look at a big box of, National Transportation Safety Board data.
Right.
They've got the data on their own so that the decisions to them are real decisions, not based on some box of data that they don't know where it came from, don't know how to trust it, don't know, the entire provenance of the data and conclusion in the data. They can derive that from literally ground miles right into data center. So,
well, speaking about real world decisions, we have the whole stock market apparently cashing out to get ready for the SpaceX IPO. So according to this account, Crypto Rover, $200 billion has been wiped out from the U.S. stock market in just 10 minutes after the market opened. So that's obviously humorous. I don't believe this is the case. This is also an article from, I think it was MarketWatch. The title says, "Looking to buy into the SpaceX IPO. This scary chart might make you think twice." And of course, there's a clickbait title for you. And it's not even a chart. It's actually just a table. Is a table a chart, technically, Phil?
I don't think so.
Yeah. So they made a mistake on their title there, probably intentionally. Because if they said scary table, that probably wouldn't have gotten too many
honestly,
views.
A picture would be worth 1,000 data points on the chart. So why wouldn't they produce the table?
Yeah.
I mean, the chart.
Yeah.
Anyway,
so what we have here is a list of companies that came public, along with where their stock was on a percentage basis 1 week after the IPO, 1 month, 3 months, 6 months, 12 months. And then on the far right side is the 1 year maximum drawdown. And so drawdown measures the decline from a peak to a trough. So it's possible, for example, for a company to IPO at a certain price, go up 100%, doubles, and then the stock to drop 50% from there back to the IPO price. So the drawdown, sometimes the numbers can seem kind of crazy, but it just may mean that it's coming back from a really big peak. The first example here is Facebook. The stock was down 17% after the first week after the IPO. After the first month, it was down 18%, and after 3 months, it was down 45%. 6 months down 42, and 12 months down 31. So if you bought Facebook at the IPO, you weren't a very happy camper for at least the first 12 months.
I did that.
Yeah.
I literally did that. Yeah. Well,
you look at Twitter, it did nothing for the first month, apparently, net. And after 12 months.
So in other words, it was the star performer.
Yeah, exactly. Relatively speaking on this chart. Still down 58% from peak to trough, though, during that 12-month period.
Yeah.
You can see there's a few others there. On this page, maybe Zoom is an interesting one. 1 month after the IPO was up 45%, 3 months is up 54%, 12 months later it's up 142%. But there was a 40% drawdown during that first year.
Do you have any idea when it hit that 142%? Do you have any idea what that date might have been?
Well, the 142% is 1 year after the IPO.
Yeah. Do we know when the IPO was?
I don't recall exactly.
Feels like that was in the middle of COVID.
It could have been.
Yeah.
Yeah. Uber kind of had a tough time too. 12 months after its IPO, it was down 21%.
Mm-hmm.
And then we have another page, and I apologize on the next page. We lose our headers. But just remember that it's the 1 week, 1 month, 3 months, 6 months, and 12 months are the columns here. So if you look at Palantir, for example, kind of a slow start off the IPO, but 3 months into it, it's up 164%. And a year into it, it's up 153%. But again, there was a 53% drawdown during that time period. And that seems pretty common. The average drawdown is about 55% for this list.
Yeah.
The average 1 year return was only 14. And the average 1 week return after the IPO is like 4%.
when we finish this call, I'm going to take this, run it through an AI, and ask to give me a chart, a real chart,
Yeah.
of what it looks like 2 years out and 3 years out.
Well, and that's ultimately what matters, isn't it?
Yeah, because it is what matters. I mean,
Yeah.
not everybody here would be a winner. My favorite friend here would be Rivian, know a lot about that stock. But a heck of a lot of them would be big time winners if you look out 1, 3, 5 years.
And it's interesting too, Phil. Robinhood and Rivian here had pretty similar pathways. It looks like they had a strong IPO period, and then tailed off.
Look, I think for me, looking at this outside the negativity, I don't know, I'll say purposeful negativity of the headline, to be cynical about it. I think that most people are looking at this and saying, when do I buy SpaceX? If we're just going to get to the punchline. Yep. When do I buy SpaceX? Do I believe, because we've talked about this, I believe in SpaceX as on the 5-year and 10-year plan. I think it's going to be insane, right? But I don't know what it's going to look like. If I get this IPO allocation and I get in on day one, is it going to come 50% off of that and go on sale for me? And I think every single person is attempting to guess that, And I don't know what, you're a financial guy. You're not trying to give financial advice, but when people ask me, I say, if you can get a little at the IPO, that's sort of a hedge or a bet on things going exceedingly well or wrong from another perspective.
Yeah.
And then, your first year is probably a good year, and maybe around earnings. And I think the one thing about SpaceX that might be shocking, and I don't mean this in a way that I have any hope or wish for, I'm just saying it. So we watched the Bezos, the Blue Origin explosion during I think it was just like a dry run. We're going to see stuff like that with SpaceX. I just don't know when. I mean, if you think about it as a negative headline from Tesla might be, oh, this Tesla car crashed, massive fatality, a car is crushed into oblivion, or this car battery fire, melted a little segment of Highway 101 in California. But a rocket blowing up is a much bigger kinetic event. And I'm sure that people are not ready for that from a market perspective. And I hate to say it, but some incident like that will be probably your best on sale day. And of course, I never wish for it. I'm just saying,
Yeah, that certainly could be an impetus, I think, for some kind of downturn. The other thing I think that comes to mind for me is going from a private company where you can kind of set your own valuations and you can just have this nice stair step.
Right.
It's suddenly very different in the public market where you're at the whim and the mercy of everything.
Yeah.
And to me, with what SpaceX is developing with Starship, that's on its own development timeline. And hopefully, that's sooner rather than later, but you never know, there can be delays. And it's kind of what Tesla investors have been waiting for with Robotaxi in that regard. And then, of course, people have likened sort of Optimus development with the orbital data center opportunity.
Right.
It's a little bit longer term. Optimus is still in development. Orbital data centers is a few things to work out. Confident they will in time. But the timelines can get stretched. And as we've seen with Robotaxi, people lose faith. Even though every day that goes by, we're one day closer to the eventual, scaling of Robotaxi.
There's a bit of irony there, right?
Yeah.
From a risk adverse point of view, each day it gets closer to having value. And yet the human mind says more time that's gone by from the start of it. I mean, you have to analyze why you think the start is what it is. And from my perspective it's about them making steady incremental improvement. So risk comes off as you move forward.
That's right.
Other people would look at it and say, no, I'm sorry. This time between when they started and now is an indicator that they can't get there. I mean, in some people's mind. The weird thing about these things is they tend to happen all at once. It's like, my perspective on it is, quite clear. They're converging and they're not going to drop they're not going to hit that scale button until they converge on a happy place for them. But when they do, the market's going to look backwards and go, I mean, individuals will look backwards, just look at it and they'll say to themselves, oh, I thought, damn it. And it feels like you're just the bag holder between then but you don't know when that's going to happen.
No.
And I think SpaceX is, I think we feel the same thing with Optimus, because Tesla previewed Optimus early. In a sense, we understand the SpaceX galactic plan. I've written on it. We've talked about it. We talked about compute demand. I mean, beyond Starlink, we talked about the compute side of orbital compute side of it. And I guarantee that's going to stretch out longer than people have, comfort for. So I think you're going to have sort of some lazy summer days in the middle here where we're going to feel like, let's go to the beach and forget about SpaceX. But then it'll creep up on you, and all of a sudden, look at Starlink. It's a really good example of that. One of the ways to think about this is plot the. I've seen this too. Plot the number of Starlink satellites that were put in orbit during those early days when you saw minuscule amount of those things. Did you say to yourself, oh my God, this is going to be a big business? No, you probably said, or many people said, I don't know what they're fancying with over there. I don't know what this stuff is all about. Yeah. And for that one, Starlink is interesting, and a weird different dynamic is, it too has to get to critical mass. Starlink is very particular. It has to get to certain critical mass where it has coverage because of the way it works. Orbital data centers actually don't need as much of that critical mass to start computing. In other words, one satellite can start computing. You don't need a constellation of them. You might need a lot of them to get to that economic cross point of viability.
Sure,
but not from a in use. Like when Starlink had 100 satellites, it looked like what it was, which was nothing more than a experiment and a beta program.
Yeah.
And then all of a sudden now it's got 10,000 growing to, who knows? I mean, it's going to explode, and already is. I think, I said in a post last week that I think United is doing great, by the way, rolling out their Starlink, but I think that more Starlink satellites go in orbit per week than planes get outfitted to use Starlink and United per week. Tells you a little bit about, one looks harder than the other, in my opinion.
That's right. Exactly.
But
one's putting something into space. The other one's not.
Yeah. But
that's a good point.
By the way, good on them, though. I mean, that United should be, compared to Delta, right?
They must have one magic screwdriver that they have to use. And
I know,
they're limited by that.
Well, I can tell you a little bit about their workforce if you want me to, what the ground workforce looks like. So,
well, let's not delay any further. We've teased a demo, and so let's go there. I understand you've built something pretty amazing.
This is going to be wild, and we'll see. Please call an audible when it gets if it doesn't continue to entertain. So let me do what I told you to do, which is get set up for us to talk.
Yep.
Now you can show my screen and let me know when you do see the screen, please.
Yes, it is ready to go.
Okay. So I built an app, folks, and I call it NetP, and I call it NetP for no good reason, because maybe my name is Phil, and it's all about networking. And just to kind of give you a little bit of background here and motivation for why I did this. Well, first off, I love networking. I've been involved in networking side of computer science literally my entire career. Most people think of me as the Rivian guy, but when I worked at Apple, 2 tours of duty, I did a lot of networking stuff. I built network stacks. I've written TCP stacks from the ground up. So I love networking. And so that's one thing. And I've always wanted to write this this geeky app. And the motivation of the app was really simple. It's like got my iPhone sitting in front of me. Am I connected to the internet? Yes or no? Now you might think, well, normally is. No. You always end up with that. I'm on a plane. Am I connected to the internet? Am I getting any data through? What's it look like?
Mm.
So I always wanted that app, and I wanted to do something else. Like I said, I keep talking a lot about AI. It might be a really good idea if I use it. Like I shouldn't speak about something without a lot of good direct knowledge. And I feel like I've stretched that a little bit with my knowledge on AI. So I got really deep and I built this app. And so I'm going to demo it to you. And the way I'm going to do it is I'm going to demo it on my phone. It's actually running. So if you look at the screen to the right, it's running in it probably looks like an iPad on my screen, but really what it is a Mac application. And it just so happens to be that on Apple Silicon now you can distribute made for Mac iOS apps.
Mm-hmm.
But what we're going to do is, and hope this works well, is I'm going to connect to my phone. And I hope you see that. Do you see that?
Yes. Device not connected. And now we see that. Yep.
That's okay. That should be okay. Yep. That's something else. Let's just go to the home screen here. So this is my phone. It's in my hand.
Mm-hmm.
And I don't need to do anything with it anymore because it's on screen. It's shared through iPhone mirroring technology that Apple built into the latest Mac OS. So here's the app right here. It's called NetP. And I'm going to launch it. And when it launches, it immediately determines that, in fact, we are connected to the internet. We're connected by Wi-Fi. We're on this SSID, in other words, what the Wi-Fi network is called PB. It stands for Phil Beisel. That's, if you come to my house, you'll see PB. It will tell you immediately what ISP, Comcast here. And right out of the gate, it starts doing one of your famous speed tests, a speed test using a particular speed test algorithm. And it shows that it's pretty good. I'm getting almost 200 megabit service down. And believe it or not, I'm getting massive upload service right now. Normally that's quite asymmetric if people are used to it. You really pay for your download size principally, right?
Yes. Yes.
Most of the data is coming at you. So that's what you're paying for. However, you can see over here on this side, if you look at the Mac-based one, we'll run it on the Mac too. They're both connected to the same internet. Unfortunately, the Mac one doesn't show the physical Wi-Fi you're connected to because of the way Apple built it. But so we'll run this one. We can either let them run automatically or we can run them on demand by just clicking the little run button. And you'll notice that this one, it's close. They're always, in some portion of time they get close. So you can see that one's a little different, but it's okay. I mean, that's everybody that's done a speed test. The speed test algorithm that it's using, by the way, is the same one that's here. If you go to Google and you type in speed test, it's the same one that's here.
Okay.
You can actually switch the algorithm in the app, but that's the one out of the default one.
And are those speed tests, is that default Google speed test, is that accurate? Are there issues with the way that is done, or is that as good as any?
I think the Google one, and it's not Google, by the way, it's called M Labs, I think, Measurement Labs, is good because what they do at the beginning of the speed test is they find the nearest server that's closest to you physically, but past your ISP.
Mm-hmm.
So what you don't want to do is a speed test. Like, let's say that the download you're doing is from, you're in the US, you're doing it from Germany. Well, you're way past your ISP. So what are you measuring now? You're measuring all the other internet traffic between,
Yeah.
And so M Labs tries to look up the best close proximity. Sometimes you don't want that. And so I have other algorithms in the settings that you can switch to. And then you can see below here, you have a latency graph. Latency is an important consideration. You can see that on either of them, they're roughly the same, about 28 to 30 something, averaging milliseconds. And you can ignore, jitter kind of gives you an idea how much that's moving around in time. The lower, the better. And then you have like high watermarks and low watermarks, and you see a running graph, and this is running at once a second. So if anybody recognizes what's called an ICMP ping, it's basically pinging a server and returning a result, and it's measuring the time.
Mm-hmm.
It's very little data, but it's measuring the time. And that's cool, because it kind of gives you an idea. Now, the difference between the top one is measuring your bandwidth at a moment in time.
Yep.
And the bottom one is measuring your latency. And a good way to think about that representationally is that bandwidth is sort of like the width of the river, and latency is sort of like the speed of the water running down the river.
Mm-hmm.
So if you had a very, very wide river and it was moving very slowly and you were collecting the water out of it, you might collect a lot of water. But if the same river was running twice as fast, you'd collect twice as much water, right? So latency is important in networking, and it's important for other reasons. Like, for example, right now we're having a conversation that we're having a video conversation. It is effectively live, although when the viewers see it, it's pre-recorded, but it's live between you and I, certainly.
Right.
That requires very low latency. And that's the story of why, we're going to talk a bit about Starlink in a moment here. That's why Starlink is so amazing, because by having low Earth orbit satellites, it can have a very low latency. If you try this on a United plane, the numbers will look like this. And if you tried it with the previous service that they have, I don't know, Viasat or whatever is there, maybe Globalstar, you're going to get much higher latency numbers and very, very poor speed numbers. So this app will test these things for you, but it also dynamically lets you know whether you're connected or not. Now, here's one problem. In the demo, I can't show you the disconnected state, because if I show you the disconnected state, actually, maybe I can do it on the phone. Yeah, I'll do it on the phone in a moment. We can't really disconnect, because then our conversation would stop. We can't do it on the Mac, for instance. But
Yeah.
Let me show you. Let's do this. Let's go back to the home screen, and let's switch networks here. And so I'm on my Wi-Fi right now, and what we're going to do is we're going to switch. Hopefully, we're going to switch to Starlink. So I have a Starlink Mini. So I have two Wi-Fi networks in the house, PB, PBX, and I have Starlink Mini. So we're going to switch to Starlink Mini. And as it's switching, we're just going to go back to the app and see what it thinks. And sure enough, the app immediately changes. It now recognizes that, in fact, it is connected to Phil's Starlink Mini. It starts a speed test, and it looks like it's going to get pretty happy 100 megabits. If you compare that to Comcast, we were doing about 200. I've seen this up to 170 or more. I think maybe, I'll show you that in a moment. We'll show you the best numbers. And of course, the uplink is more representative of what it should be, very low number compared to the downlink. But what's cool here is, take a look at this little section. Because it recognizes it's in fact Starlink, it switches the display. Instead of just having the Comcast panel over here, because remember, the Mac is still connected to Comcast. I didn't switch the Mac's connection. I just switched the iPhone's connection, and that's literally this physical device here. So if you see that, it'll actually tell you, much like the Starlink app, that whether or not the dish is aligned, or the panel and a transceiver is aligned. It'll show you the actual physical downlink. In other words, what kind of data is traveling down at the moment, and what type of data is the amount of data traveling up. And it will show you ping to ground. And this is actually a really cool number, because compare the ping to ground number 17, versus this number down here, 23. What ping to ground is, it's saying from my transceiver through a satellite to a Starlink ground station and back is 17 or 18 milliseconds.
It's amazing.
Yeah, it is amazing. And that's why this Starlink rocks. And what we can do here with Starlink, we can go into these abundant advanced settings I have. Oops, why is it not? I feel like something is not moving here. It's not scrolling right for some reason. I don't know why.
This is always the risks of a live demo.
Yeah, that's okay. It is live. That's cool.
So, live between you and I, anyway.
Yeah, exactly. Yeah, I don't know quite why it's not doing what I want it to do, but that's okay. Oh, there it goes. I think I was doing this. I was doing it wrong. I don't run it this way normally. So in Starlink, I can put extended info, and you'll see that it actually pulls up a graph here. And I didn't mention this little guy down here will tell you roughly, not always, but when you switch to a different satellite, it'll reset this little graphic of the satellite going across the sky, so to speak.
How long does it stay connected typically to one satellite before it needs to switch?
Well, I don't really know. They've stopped advertising that. It's anywhere from about 15 seconds to 4 minutes. And one of the reasons this is true is the satellites are traveling close to 5 miles an hour a second overhead.
Yeah.
Which is extraordinary. 17,000 miles an hour, which is roughly, I think, about 4.7 miles a second.
You said 5 miles an hour per second, but it's really 5 miles per second.
Sorry. Yes.
Yeah.
I think about 4.7 miles per second across the sky, or 17,000 miles an hour in other units. Yeah.
It's pretty zippy.
Yeah. So what that means is that you don't have very long until your transceiver. So the transceiver is doing, has a technology called beamforming, and it is actually basically using its antenna array. It's not, the transceiver does not need to physically move at all. It's got approximately 1,000 antennas on the surface. I don't know how many on the mini versus the standard. The panels are much different in size. I write about it in my article on this Starlink, so I just forgot the number. And all these things are essentially tracking that satellite, and so they're moving. In other words, the beam, the RF signal, is being bent electromagnetically towards the satellite as it motions, and vice versa. By the way, the satellite is also speaking to it, so it must do the same. And then when it switches, it just jumps back, in a microsecond to the next satellite. And from your point of view, you see no outage. Yeah. It immediately links up. It's sort of like a cell tower switch, except it's happening a lot more frequently than a cell tower switch.
So you built this by staying up late at night and hand coding the software.
Yeah. Well, no. Yeah and no. I'm going to give you a cool demo, but let me just run you through a couple more features real quick.
Yeah.
So one of the cool things is, what instantaneous data is really kind of cool, but what does it look like if we take a look at all of our connections over time? What if we roll them up and just look at on each of our Wi-Fi? So here's all my Starlink data. Here's all my data on my PB Wi-Fi. If I have a Starlink terminal, this little tab shows, so I can just focus in on the Starlink ones specifically. Top will show me my top data connections. Like I got this one the other day, literally close to my router at almost over a gigabit downlink speed from Comcast. But not too shabby. On my cellular at my local shopping center, less than a mile away, I got almost a gigabit on my iPhone. That's pretty cool.
Yeah.
The power of 5G. And I think Starlink would fall down this list because, it's not, probably somewhere it's in here. No, it's not my top connections. And then it figures out where your locations are, so you can either name them or see how they're attached. On any one of these cool things, it will allow you to kind of see where it is. So like, for example, let's go back to the top. Let's go to the shopping center one. Just click this little guy, and you'll see, oh, it shows the entirety of that link from my house to the shopping center. Not to be outdone, so all these stats are connected to a cloud-based system, and they roll up. Let me show you the roll-up graphs over on this display. So this little, this little connections icon down here, you can click that guy, and you can go over here, and you can click this little globe, and this shows the data globally. Mm-hmm. And so, for example, we can take a look at all the connections across the entire system. By the way, there's only about 50 accounts today because it's in test mode. It's not really in the App Store yet. And by the way, we will, at the end of this, we'll leave a link for anyone to try it by running it through test flight, and I'll explain briefly what that is in a minute. And so we can look at across our different providers. Like we can look at Comcast. These are all the ones that have so far come in. We look at T-Mobile. We can look specifically at, say, Starlink. And what's cool with Starlink is we actually extend the data and we get the ping to ground numbers and the maximum downlink and uplink speeds. And this is, by the way, across, like if we look at it, this is showing data from 448 separate connections that have, in other words, connection times onto Starlink. If you look at the all connections, you can see that, that's a larger number of connections. We can also look at the map of this data, which is kind of cool. We can see this mapped globally. Mind you, the data is still pretty sparse because of the fact that we just don't have many users in the system. But imagine what this looks like after you get 10,000 users. So look at maximum download speed. And by the way, this data point over here, this is Randy Kirk in Hawaii on his summer vacation. So he got 184 megabits per second. And then, just not to be outdone by cool vacation spots, friends of mine over in Cancun ran the app. They showed here. I've got some people on the East Coast, and we got a lot of data points in the Bay Area. I mean, look at if we zoom in the Bay Area, this gets really cool.
It's pretty good density in the Bay Area.
Yeah, I mean, again, this is only but take a look at all of these. I mean, and by the way, this is my neck of the woods down here. So I'm around. In other words, there's a lot of connections. Here's a crazy, route where I was kind of really far off the path, getting lower data rates. Mm-hmm. Not to be outdone in features. If you look at, there's a whole section on where you can actually record the data, and I'll show you the recording of that data. Which is kind of cool. The last recording I did was here. I think it's this previous one. Maybe I named it. Maybe I didn't. Yeah, I think it's this one. I didn't name it. If we look at the map of this, you can actually see I did kind of a loop starting at my house through this off-road connected area. And you can see when you zoom in on this map, the disconnected segments, basically no cell connectivity here in the oranges.
Mm-hmm.
Yeah.
Pretty frequent.
Okay, so now this is about half the demo. The other half is, how did I build it? Well, through my entire professional career since I was a kid, I've been handcrafting code. I've written in every language known. I think every language that I've been experienced. I'm not a COBOL Fortran guy, but I've done a lot of BASIC. I've done Pascal. I've done C and C++. Done tons of Python. I've done Swift. Swift is the language. I've done C#, Microsoft. Swift is sort of the modern language that Apple invented to build iPhone apps, iPhone or iPad apps. So did I handcraft this code? No, I didn't. I architected it, but this one I programmed in English using AI. So I'm actually going to give you a complete live demonstration of that, which I think will be kind of cool. And what I thought I would do is, if you click this little gear, the settings in the app, and you'll see down here in the right corner of the footer, there's this little icon, and if I click it, it says About Me. was built by Phil Beisel, blah, 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 about the developer. Maybe I should have a about the app. So what we're going to do is I'm going to show you how that works. Here's Cursor AI. To give folks some familiarity, there's really, I don't know, there's a couple AI coding platforms. Anthropic is probably that's a prime key reason for its business. Cursor's out there doing this. Cursor's quite excellent as well. I'm using Cursor here. Cursor is the company that SpaceX has an option to buy on, right? They've got, I think they can decide do they want to buy it or not in a couple weeks, or I don't know what the time frame is. But so Cursor may be a SpaceX company soon. Do you know the? Right. Do you know the deets on that?
60 billion price. They can walk away and pay him 10 billion. I forget the time frame.
So and they're using a lot of either Cursor data or Cursor technique on data to train the Grok build system, right? Which is sort of their answer to it. So I think that they're in a race to determine whether they want the core Grok technology. But here's what we're going to do. We're going to actually build this feature. Now, it's not going to look great to start, but we're going to build it. And I'm going to say, okay, here's what we're going to do. Here's the AI. I'm going to say, in the settings panel, there is a little icon about the developer. I want you to add one next to it that opens a panel that says about the app. Describe the app as you know it in that panel, and we'll go from there. It's pretty much English, right?
Pretty much. I wonder if you used Shakespearean English, if it would be just as effective.
Well, I mean, there's a real AI behind it, so you can. It really does infer many little things. I mean, I can make spelling mistakes, and I could say, instead of say about this developer, I could say about me. Doesn't care. It's like talking to any AI. It's just that it happens to really understand the code side of it.
And even that last part of your prompt where you said, and we'll go from there, that's really totally unnecessary.
Yeah, correct? Totally unnecessary. It's almost like it's just a matter of it's just sort of starting to have human conversation, right? I mean, it's not really teeing it up. It doesn't really care if I'm going to modify it after. It doesn't. In fact, the beautiful part about it is, unlike hundreds of developers I've managed over the years, there's no laziness here. Right. If I was managing a developer and I said, "Hey, I want you to write this feature," and then the next day, after 2 weeks of him writing the code, him or her writing the code, I said, remove it. There'd probably be an audible sigh, right?
Yeah, all that work down the drain.
But it doesn't care. It'll gut code that it wrote. In fact, it doesn't even claim much responsibility for the code it wrote. A lot of times, I'll say, "Why does this code look like this?" And it'll say, "Yeah, this is completely not clean." And I'll say, "But you wrote it." So
it's like having an employee with no memory.
No memory. It doesn't lie to you, but it's and I will say some things about it in a minute. But we are letting it do it now. Okay, what is it doing? Well, it's writing a bunch of code. What you see on the screen is literally little snips of the code it's writing. It's quite busy. It may take a minute. It may take 5. We're just going to, because it's a live demo, we're just going to spend the time. Right now what it's doing is it's actually using the tool to compile. So it's writing a bunch of Swift code, and it's using the Xcode command line tools. I'll explain that in a second. That it's basically checking its work. So it's very close to finishing this feature for us. Now, we're not going to look at the code it wrote, and I think that most of the audience here probably isn't interested in looking at the code, but we are going to look at the result. And the way we're going to do it is we're just going to rerun the application here, the Mac-based one, and it looks like it's almost done. Honestly, I don't know how close it is. I mean, I've kind of gotten used to what it's doing here. Some features take longer. I've asked it to build some very extensive features. Direction from me directing it, I would say that, if you think I told you I built this app, a client side and a server piece in 3 weeks, and I did it with this AI, you'd think, wow, that's pretty stunning. I will tell you, it is a lot of my experience going into how I'm instructing this tool. Mm-hmm. It's like essentially what I am is a senior engineering manager directing a team. Okay, it's done. It tells you what it did. Now we're going to either like or hate the result, but let's give it a whirl. So now we're going to run over to Xcode. Now this tool is the tool that is where you build applications for the Mac, and it has changed code behind the scenes. In other words, it's changed a lot of code. All I'm really going to do is just ask it to compile and run it. And what you're going to see is it's going to basically pretty quickly flip out this display and run a new version of the app. Okay, so you can see it says up here, building 29 of 43, say files it's compiling. Compiling is the right word. And then it will link and build the final app, and then it will launch it. And why will it launch it? Because I've had it set up here, my Mac. So there it is. It's about to relaunch it. Here it comes. Okay, believe it or not, this is not the same app. I mean, it is. It has this new feature in it. Let's go see what it looks like. First time for this, folks. Aha! There's a new button here. Let's see what it does. There it is.
There it is.
Let's see what it thinks the app is. Interesting. Usually it doesn't get this beautifully right, but NetP is a network testing and monitoring app for iPhone and Mac. It gives you a live picture of your internet connection, what network you're on, how fast it is, and how stable it is over time. The main display, history, blah, blah, blah. Okay? Mm-hmm. So I'm not saying I'll keep that, but it's pretty cool. And for the first time, I'm programming in a new programming language called English.
It's amazing, isn't it?
It is. It is stunning.
Yeah.
I don't even know how. I mean, I have little anecdotes about like what it did because I didn't know like what it was capable of. So I have a whole server side to this that I'm not going to demonstrate. It's running on Amazon Web Services. It uses Lambda functions, DynamoDB, S3 storage, and that's how we get to these galactic roll-up features of these maps across, connections. In fact, this thing here you're seeing on the screen is a server-based view. In other words, it's a web page that's available to the users as well. That's sort of like a roll-up of the data. I've got a connected account. I've got Phil Beisel is connected to 2 devices, the 2 that you saw today, the Mac version and the iPhone. And here's sort of a roll up of all my data on the iPhone and all of my different my Wi-Fi connections, my cellular connections when they happen, and then all the different ISPs that I've interacted with through the app. Kind of a heat map of that data. So this app is completely different. This is like just a standard HTML app, and I've asked the Cursor AI to manage that app as well. And I told it, build it, and for a while I was hand deploying it. Like you have to do this, there's tasks you have to do to get it to be live on the server. Mm-hmm. And I found out that I didn't need to do that. I just need to say, could you deploy it? And it's already got the credentials to connect as from a developer point of view into my Amazon account. So for example, I could build a feature today that changes this in front of our eyes as quickly as I did the iPhone app.
So let me ask you this question. How does Digital Optimus or MacroHard make this even better?
It's a great question, Cern. I don't know what it's going to be yet.
Yeah.
However, the difference primarily would be that it should be able to drive all your applications on your computer. This is a very specific thing we are doing here. We're coding an app. And every single person listening to this at any experience level could build some version of an iPhone app tomorrow using this tool. Could they craft it this way? I don't know. That depends on your experience level. And the tool will make lots of weird mistakes sometimes that you don't, like you ask it, why did it get slow here? And it will tell you, oh, the way I went off and did this was like this. And you're like, oh, that's completely wrong. You got to start over. You've implemented that wrong. So I don't give it too much rope to hang itself, if you will.
Yep.
In the case of answering the question of macro hard, what I think we're going to see there is an experience where it's going to be able to drive other things. It's going to be able to say, like, for example, I could say in the macro hard tool, take this data and build me a Google sheet. And in that Google sheet, I want it to build a chart that looks like this, and this from the data. And I want you to be able to do that, every week from the server data, because I don't like what Phil did. He didn't build enough features into this app. So I want to slice the data a different way. So you could say, and then it has nothing to do with programming at that point. You're just basically saying, geez, if I had access to the data, Phil gave me access to the data, or there's enough on the screen to scrape. And that's a good way of thinking about this. It's sort of like that macro hard should be able to look at, say, the screens that I showed and basically just pull the data directly from those screens live or over time and do something else with it, whatever you want to do with it. Build a presentation, build a spreadsheet, build a presentation on, I want to complain to Comcast about my connection speed. So I'm going to build, gather up 50 samples, build me a PDF and send it to the CEO of Comcast and tell him why his service sucks. Is that kind of thing.
Is one way to think about it, perhaps, then what you did here with Cursor is build a tool. But what macro hard will do is use the tools.
Yeah, that's a good way of thinking.
Not so much build tools, I guess it could, but it's maybe just more using the tools that are on your desktop, and it's just doing that in an automated way.
Yeah, it's a very reasonable way of thinking about it. I mean, the truth is that, when you think about Xcode, which is that programming environment that's Apple's product that builds iPhone and Mac apps and iPad apps and watch apps and so forth. That environment, I mean, we're essentially driving it, right? We're essentially driving it. Now, we're not driving it. It's, you don't watch it and it's like pushing buttons and writing code on the screen. We're writing code into a file behind its back, and then we're just asking it to compile and run the application. But in case of how macro hard may work, is it may be more deliberate in terms of what we see agentically operating on our screen. We may see, it opening things, or maybe we just say, go build a spreadsheet. I don't really want to see what you're doing. I don't really care. Just build the spreadsheet. When you're done, show it to me. In that case, the spreadsheet's sort of done. But is it done? Because it's a tool too, right? It takes input data and it may compile it into a chart. So in a sense, what we're doing here is we're moving programming or instruction from very, very low level stuff that computers understood, from 50 years ago, and we're moving up the stack to the point where we're programming in English or instructing in English, the language we know, the programming language we're best suited to know, and by the way, is more heterogeneously available to all of us, as opposed to people that are specialists in the field. But the same thing with like Excel, right? I mean, or Google Sheets or whatever. It requires some knowledge of those. So if you said to it, lay out a spreadsheet, you're now programming in a new language, and that is, and build it such that it keeps a running some of these columns, and you're talking at it that way, you'll get the outcome. You might say, I want all red, all negative data in red and all positive data in green. Well, have you ever had to look up that functional way to do that in Excel or Google Sheets? There is a way to do it, but you have to know what it is.
Yeah.
But here you don't have to do that. Just like we built that feature, I don't need to know about the view system of the app. I might complain that I don't like the way it did it. Like, I don't like, by the way, change the wording, and by the way, you can do anything here. So macro hard, I think, is just like up leveling it to work that's beyond the craft of programming to generally using any of the tools that are available on our PCs, Macs, or iPads. I mean, I don't know what runtime they'll give you when they start, but something like that. Yeah.
So the thing that's interesting here, just back to the programming part, the thing that comes to mind is you think about the days of early days of photography, right? Expensive equipment. Only a few people knew how to use the equipment.
Right.
You needed to be professional. And then all of a sudden we get to an age where there's cameras for everybody. Now, the quality of those photos initially weren't very good. And that took some time. And then, of course, now with digital photography, the quality of photos is way superior to what we had in the days of professional photographers. And so you've democratized photography. You have an explosion now in the number of photos that are taken every day. Like, I don't know how many photos everybody has on their iPhone, but it's probably tens of thousands of photos, right? And you've massively reduced the cost. So are we going to see this exact same thing happen with programming, where everybody essentially is going to be a programmer? You can just use your iPhone, for example, and dictate with your voice and say, hey, build me an app to do so-and-so.
Yeah.
And it'll just do it.
It's funny, because one answer is, of course, and yes, for those apps that people could invent. I'll give you an example. A friend of mine, 10 houses away, is about my age, and he's trying to get U.S. Masters record in shot put. He's a pretty amazing guy. He was in the Olympics doing shot put, so he's a pretty amazing guy. Mm-hmm. And he trains locally. I've watched him, by the way. Throwing a shot put is insane. And he built a shot put app using Anthropic's Claude Code environment. Sort of think of it as at least analogous to Cursor AI that I've been using. And I looked at the app and I'm like, Alan, this is pretty full functioned and amazing, right? He's like, yeah, I just built this. And I'm like, wow, and by the way, he knows nothing about programming languages or anything like that. And I was talking to him 2 days ago, and he said, I was hoping you could give me help with a feature I want to add. And so this is where you get yourself in trouble. And I'm not saying he's gotten himself in trouble. We talked about it a bit, and it takes a bit more doing. But he basically said, the way I've organized this app is I have data input sections, and there's segments of the throw. And I know nothing about shot putting other than it's really hard. And he showed me how he segments data inputs. And now he said to me, well, what I want to do is I want to take video of me through these segments, and I want it to analyze the video and fill out. And I'm like, so he's basically saying, I want to go from 0 to full biomechanical analysis. The full, like all the way to the finish line of stuff that's been, people may have seen, like how they do biomechanical analysis of any kind of motion, tennis or golf. In the past, they put these little dots, and they auto digitize it in stick figures, and they could, by going frame to frame to frame through the video, or a computer going frame to frame, they could digitize that motion, and then know things like in golf, they know like the velocity at which the club hits the ball, and yada yada, and
the angle of the club and all that stuff.
Angle and every possible thing, because it's a 3D reality. And I thought, when he asked me about that feature, I thought at first, you have no idea what you're stepping into. That's really effing hard. And then when I walked away from the conversation, I thought, wait a minute, what do I know about that? Like, how do I know that the AI can't do that? I'm thinking of it from my experience and thinking, I know how hard that is to build that thing. And yet, some of the features I built into the app you just saw are really, really hard. Like, just to do the dynamic live graphing seems like trivial. Do those little gauges seems trivial. No, it's not. If I had to handcraft that code, days, an app that took me start to finish so far, I'm really not at the finish line, but it start to some level of polish, which is about 4 weeks, and maybe 3 weeks, and we'll call it halftime, 3-4 hours a day. Maybe I'm lying. I'm kind of a perfectionist, so I'm in there tweaking the hell out of it. But it looks like it's ready to go.
Yeah.
And it kind of is. Looks like it's ready to go. And as I step back and I look at that, I go, how much is it? Like I can imagine what it would take for me to do it on my own. I could imagine what it might take for somebody if I told somebody who's nothing about programming, I want to build this, or here's what speed test looks like, and here's what graphing latency looks like, or think about latency. Go build me an app. Would it look like this? Would it feel like this? Would they think about the features? Would they think about the architecture? And I've come to this conclusion that we are entering a very, very topsy-turvy world. And it goes like this. I have spent 30-something years getting to a point where I can build this app on my own, know about what it's doing. Like I understand the networking stuff quite intimately, if you will. Mm-hmm. Know how to architect the app, like in ways that make it scalable and growable. Like you add a feature, I now know what the layering of the data is. And I'm instructing it in these ways, okay? And what am I instructing? Effectively, I'm instructing a junior programmer in a way.
Yeah.
A very good one. But I'm instructing a junior programmer. Now, if I step back from that and I think, well, what does that do to a grad that comes out, a good computer science trained grad out? I don't need him, right? But where am I going to get the me's? Like if I don't have these people working through their careers, through the experience of all this, and I don't know where that comes out yet in the wash, but it's definitely something we've never, well, maybe I don't have the right analogy for it, but where in the economic standard cycle have we ever seen this topsy-turviness where, well, maybe you'll say something right away, where experience pops in and directs, and you don't need, like, I don't know. It's a crazy thing that I can't see out 5 years. When you ask me about apps, can anybody write an app?
Yeah.
Well, my real answer is in 5 years, no one will write an app because no one will need an app because apps will be useless because all we'll be doing is asking AIs to do things for us live. We'll say, hey, can you sample my latency on my 5 networks across, now, or, repetitively at midnight and 7 a.m. every day. And I want to get, I want to build some graphs to see if I'm.
And you would say in the style of that old NetP app that we had a few years ago.
In that style of that old NetP app that was so cool then.
Yeah.
I want it to look like that, but I also have some features I want to add, and by the way, it's more about just like driving to function at that point, right? As opposed to here, we think of it as, I've talked about this, I've written about it, is we're not probably going to be in a universe where we think of, like people said, well, how would Elon build a phone? And I would say, well, if Elon built a phone, it wouldn't look like phone for today. It would look like a communicator device, an information device. It would certainly connect to the internet, Starlink in particular.
Yes.
But it would be an AI device, and we would ask it to do the things we wanted to do. And we would say things like, what's the weather in Nashville right now? We would just talk to it, and it would learn and remember. So if we opened its interface and we were to stare at it, it would probably present to us the most relevant information that it thinks we would be asking it to. Frankly, all the apps that we typically open would kind of just be information at our fingertips in front of our eyes. And if it's not there, we'd just be able to say, why are you throwing me Nashville information? I'm not going to Nashville. I'm going to Frankfurt. And I'll be there for the next 2 weeks, or I'll be there in the next 2 weeks. Switch all the stuff that I like to know about Nashville to Frankfurt.
Yes.
That's
and if you're doing anything outside, it automatically considers the weather forecast without you asking it.
Exactly. It knows what stocks to track and when to send you the information on that. Maybe you get up in the morning and you open up the Apple stock thing and you look at your Tesla stock and you look at your soon to be SpaceX stock but why is that true? And what, because you're interested in these things. Oh, so you build dashboards that information is readily available. Well, you don't need to build a dashboard in an AI universe. You could literally say to the AI, build me a dashboard of the most important stuff. In fact, that's probably what it thinks that it wants to do in the first place, and present it to me. And then it would contextually know what information is important at what time, where you are, what time of day it is, who you're interacting with, and that's the future, I think. So I think the future of apps, there is no apps.
Isn't that, again, I think the photography analogy is still pretty interesting for this, because on one hand, we probably have more professional photographers today than ever, but we have an absolute explosion of people doing it themselves.
Yep.
Right. But if you want to get, wedding photos done, you don't do it on your iPhone. You might do some video on your iPhone, but you still pay a professional photographer. So I wonder for developers, if we're going to have such an explosion of software development that people can do on their own, but yet the demand for people that are true experts that have the experience is still going to be very high.
Yeah, I mean, I was thinking as I stepped away from this, because this is an interesting passion project for me. Love networking. Wanted to build an app this way. It's a learning experience. I have the time to do it. I was thinking, hey, you know what, Phil? You're more valuable than ever all of a sudden. Because you can instruct at a much higher level what you're looking for from an outcome perspective. And let's say that I was a professional photographer as my, that was really my career. In a sense, with AI, I might be more valuable than ever, because for the first time, I have that eye and know what color correction looks like, or how to get the scene. So even if there's a plethora of cameras surrounding the subject, or AIs that could do the photography without, I'm going to want more of the raw pixel data in the stream, right? So then you can see that Apple's already doing this, right? They're starting to, they're in the thick of these much denser of collection of the pixel HEIC formats, these formats where the finished photo, like what we would do today with AI is we would take the finished photo and ask it to modify the finished photo. Well, in a sense, we would much rather it probably work from the source data.
Yeah.
Right. And so instead of thinking of it as, sort of way how you might think about FSD in a way, right? When we see a picture of what the car produced out of its cameras, that's a distillation that's made for the human consumption. It is not what the AI consumes.
That's right.
Feel like if you said, build me a picture of what the camera is inputting into the AI, it wouldn't look like the picture that we're used to. It would be off. And we would be like, who can see that? The FSD can see that. Yeah. Yeah, that's what's super fascinating about it. So I think a couple things. Raw data, the rawest of data, some of that can never be reproduced. So you want to capture it, data samples, whatever it is, whether it's FSD or digital photography or networking information that I have here, right? Like I can't tell the AI, hey, I notice Comcast is slow, or Starlink appears this way. How many times did it switch satellites in this period of time? Well, it could say, based on where you were and based on the data you collected, I think 52 times. Okay, is that the real answer? No, that's an estimate. Well, what's the real answer? Well, I don't know. Give me the data and I will tell you more about it, like how long it was on each satellite and when did it switch, and did it get errors and handoffs, or that kind of analysis. You got to go to the source data.
It's interesting. I think about too the possibility of the average person creating something that allows them to analyze whatever it might be in a way that was never possible before.
Yeah. Yes.
So, for example, you think about, just to go back to the Robotaxi network, we have this RoboTracker website that basically keeps track of the number of vehicles. But if whatever public data source you can get your hands on, you can reference it with any other public data source. And it's, you can analyze this in any way you want and use AI to program that all for you,
right,
in a way that is dirt cheap. I mean, the possibilities are just endless.
There'll be a point in time where the way that app could look is, how about I make it, here's my app. I want to zoom into Austin at, you give me cross streets, I don't know, Austin, at, south and whatever, at 4 PM, and I want you to give me a virtual view of all the cyber cabs that go through the 3rd and South intersection.
Yeah.
So all of a sudden it's building dynamically.
Yeah.
And when I say that, I'm asking it for, this is real data, right? It's not, and then I could say to it, hey, how many intersections, I could imagine dynamically asking an AI this question. How many intersections in the Robotaxi area of Austin are there? In other words, Tesla's Robotaxi network, how many intersections? How many miles of road? And it's answering like this. It's not researching. It's and I say, okay, I want to understand Tesla's density of operations today. So Robotaxi be damned. I mean, a nice little app, cutesy Robotaxi tracker. By the way, it is a cool little app. But in other words, imagine upsizing that to something that's much more expressive and malleable. That's the key, malleable by instead of saying, discard, let's compare it to Waymo. What do you mean? Yeah, right now, let's just compare it to Waymo. There's no Waymo data. Well, I know there isn't, but there will be. Start gathering that data and get it in the AI, because I'm going to ask tons of questions about it. It's very interesting from just sort of an AI with enough compute, which is something I keep talking endlessly on, because what I'm about, my thesis on SpaceX has been that it is the compute company. Yes. It is the infinite compute company. That's what it's really doing.
Right.
And orbital data centers are absolutely required, because we can't get enough compute on planet Earth to satisfy the compute demand. And if you don't think that's true, well, listen to some of the questions I'm trying to ask of an AI.
Yes.
Reproduce this scene, do this, do that. Imagine that type of analysis tool, aka sort of macro hard on steroids, or just macro hard maybe. I want you to do all this stuff, and I want you to do it for me. And I expect it to be fast. And once you get used to a tool's ability to do heavy lifting, you really get used to the tool's ability to do heavy lifting.
You rely on it.
Yeah, I mean, what's funny is when I started doing this cursor project, I thought I would look at the code. Do you know how much I've looked at the code? Don't look at the code. No. I do ask lots of questions about the code it wrote. And that's really the kind of questions I want. It's like, I told you to build this feature. How are you storing this data? Oh, no. Start over. You're not going to store it this way. That's crap. That's not scalable. What happens when I get up to 1 billion data samples? Oh, it doesn't work then. Okay, so why didn't you think that way out of the gate? One of the things that you have to do with these AIs and the cursor is you should be very instructive. Like, I had a fight with it a couple days ago. And one of the things it really does very oddly is it can sometimes express a beautiful UI like that. You saw with the About box we built. That's pretty darn good. I mean, it isn't awesome. I don't know I haven't read the text completely, but it's, it figured out how to lay things out, and it, came up with. But then if I start getting into the nuance, I want to move this over a little bit, it starts fighting with itself, its previous code. And so it will take my requirement, move this to the left, and then everything else gets moved a little bit. And you're like, wait a minute, why did you do that? So at one point, I said to it, after fighting with it for an hour about a layout, which I was like, okay, this is not why I want to be in this tool. It's like me telling a junior programmer, move that 3 pixels, and he does. Or like, imagine a carpentry example. I say, hey, add this little thing into the bathroom, and you come in, and then they move the bathroom. Like, what? I didn't tell you to move the bathroom. I said, put another sink in there. Oh, well, I thought, if you're going to have a sink in there, it better be closer to the kitchen. Like, what are you doing? So I've learned in this tool that I've had fights with it. And the fights are very weird because it's like, and then I finally said to it at one point, I'm getting really tired of this, right? How can I better express to you what my actual requirements are? Tell me how to better instruct you. And what it said to me was pretty interesting. It said, well, I want you to tell me all your constraints. And you're thinking about that implicitly. Well, I'm not going to tell it the constraints. Like, imagine you said to this carpenter or contractor, put another sink in my bathroom. You're not going to say, oh, by the way, don't move the bathroom. And also don't, replumb the street, and don't steal the neighbor's water, or maybe steal the neighbor. You're not going to. So I said, well, how much am I supposed to give its requirements? And then I said to it, which was really fun, I said, well, wait a minute. You built all these features. I've instructed you to build all these features, and I put these requirements into you for the last 10 days. How do you not know the requirements? And it actually admitted, it said, you're right. I guess if I, kind of, and I said, okay, here's a thought exercise. I want you to tell me the requirements that would have better instructed. And then the last one is to move the thing. Okay. And now I want you to express that back to me. And now I want you to go back in time and replay it with these requirements. And I want to see how it comes out. And it came out right. And instead of me getting that, well, okay, now I know how to use the tool better, I said to the tool, how is it that if you can produce the requirements, you didn't know what the requirements were? Well, I mean, I'm not arguing with a human here, right? So
maybe LLM is lazy language model?
It's not lazy. In fact, it's a little too aggressive at times.
Yeah.
It will, it'll do what I said. Like, imagine it'll move the sink, and it'll make a 4-story apartment so it's not lazy, but it is, I don't know what the right word for it is. We can't fit it into your LM, but we can say this, that it's impressive as hell.
Yeah.
It requires good direction. The better the director, the better the outcome, especially architecturally. That's an important thing. Visually, I think you can kind of ask anybody with a knowledge of English to sort of build this app, but can you get it to stand up? And can you imagine? I can't even imagine how it would build the feature where I took the data, brought it to a server, and rolled it up and built global maps. I have no earthly idea how it would have done that. Can I ask it to take the data from my data structure and graph it in the maps and do the right clustering? Yeah, it's really, really good at that. I mean, we are in a weird world, people. I just want to say that. Like, I don't know what that future exactly looks like, but we are going through doors that we have never, ever. And really what it is it's not about, it's not a normal evolution. It's just compressed. It's compressed in time, where the acceleration on the tool, like, for example, what's happening with Cursor is, as I interact with it and as I complain or bitch at it, it is taking that experience and recodifying its next version, such that the next time, next year, 2 months, maybe 1 month from now, I use it, it's not going to do those silly things, because it's going to have learned from it. It learns, its training data is the code it produces in the instruction I'm giving it. It's stealing my ability. It's stealing, like,
Yeah.
What it's doing here is I built this app. It is now stealing the essence of how I architected this app and making it part of its existence.
Just like what your kids do.
Yeah. I mean, in a more normalized way of thinking about it, if you're a senior manager in a development organization and you're imparting knowledge into more junior level people, I guess we don't call that stealing. We call them that learning by experience of mentoring. There's a better, more positive words for it.
Yes.
And then the more I mentor, in theory, as long as they stay with my org, I get a lot in return, from that. But they're not necessarily guaranteed to stay with my org. They go to another company and they'll use, Phil taught me. Like, I have plenty of people that'll come to me and say, wow, what you taught me, I'm now doing over in here. And I'm thinking, well, you're not doing it for me.
So there's so many different aspects to what you just went through in your experience. One of the things for sure is we need to spend a lot more money on infrastructure.
You got that right.
Right. Just your little experiment with what you did.
Yup.
Multiply that by however many billion.
Yup.
And so what this chart is showing is the total CapEx from 2018 projected through 2030. The numbers in gray there on the right side of the shaded box is the next 5 years, including estimates for this year. So we did Google, Meta, Amazon, Microsoft, Oracle, and Apple spent a total of $468 billion in CapEx in 2025. That was up from 268 the year before, up from 165 the year before that. And we're projected they're projected to spend 785 billion this year. And then 2027 is just under $1 trillion. Now, the numbers up to 2030 kind of tail off. I would be shocked to think that it's going to tail off like that. I would actually expect that it's going to continue to accelerate.
Yeah, that ain't going to look like that.
Yeah.
This is a curve that is probably not flattening off. In fact, as you said, it's accelerating.
Yeah. And the interesting thing is, from an investment standpoint, you look at these companies' ability to fund this, and you look at what might happen to their free cash flow. Mm-hmm. The prediction here is for everybody except Apple on this list, basically a pretty significant dip in their free cash flow.
Does Apple look smart or really stupid here? I don't know the answer.
Well, we will know at some point in the future, won't we?
We'll know in 5 years.
Yeah. But the promise is the growth in free cash flow accelerates in the out years. Now, again, if we think that these bars are too low, then that would also imply then that this is probably too high.
Exactly.
If the revenue side of it is modeled properly here.
Oh, that's right. I mean, here's the inescapable truth and reality behind all of this. We are absolutely categorically slamming into a compute demand curve, supply, the gap. I've talked about this. I've written on it. I feel like I grab neighbors and tell them, like, hey, John, who's not even we're about to, it's what we are seeing here is a situation where, Elon sees us with Terafab. Terafab itself, if it comes online, won't even produce enough chips for what the demand is. It'll start gapping out very quickly, right? So Terafab isn't big enough. Compute itself, okay, I can build the chip, and if only I could give it power. Well, I don't have the power to give it on planet Earth, So what do we know? We know that Elon wants to build a bunch of chips, and he wants to put them in space. And some people think, well, that's fantasy. That's just, this idea of, what is that? The shell gaming it, kind of. No, that's where we have to be. And every single person in that CapEx chart has to come to SpaceX to get its business done. Every one of them.
Every one of them.
Some of them know it, and others don't yet know it.
That's right. Good point.
But they all will find themselves demanding either, I got to get my satellites in space, or I want to rent compute from you, a la Anthropic. I saw Anthropic do this with with SpaceX, XAI's Colossus data center. Mm-hmm. And I heard so many people saying, well, that's Elon Web Services. And I was thinking, no. You guys keep thinking of it as this little thing in the corner. I mean, it may be a lot of revenue, but it's not a little fantasy rent out extra compute. No, it's the game. It is what SpaceX is about. It's the prototype that they're doing on the ground for what they need to launch in space at a much larger scale.
I guess it was Sunday night, maybe early Monday. Jensen Huang made his Computex presentation, his annual presentation. And I pulled a few slides from that, and I just wanted to mention them here to you. Let's see here. I'm just going to go through this real quick. He's highlighting some of this is kind of funny. He's highlighting some of his partners, and of course, he likes the night markets, right, in Taiwan. And he steps over and says, I want to recognize some of my partners, and he's pointing out the fruit lady.
What is the fruit lady?
It's a woman in the night market that sells fruit to him. Right. And then there's also the Huang rice dumplings company, Huang. I'm not sure what the name is. JI.
Why did he do this? Is it?
He was just being funny. He was highlighting, some of the real partners, but also on his list, he had some of the companies, some of the people at the night market.
I think that's a great way of poking fun at these partner sheets, by the way. like you just told me that. I was like, this is really funny. Like,
look at the screen of how many partners he has on here.
Yeah, and by the way,
this one in the corner says fruit lady right here on the lower left.
Yeah, fruit lady. Did he mention that, or did you pick that out yourself?
He mentioned it. He specifically walked over and held his hand up. Yeah. And he posed, he kind of posed for like a photo or something. So I thought that was pretty funny.
He's like Steve Jobs, by the way. He has one outfit and 70. Yeah. When I say one outfit, it doesn't mean he has one set of those sneakers and one of those jackets. Maybe he does. But Steve used to have all those, black shirts in his closet.
Well, I'm sure that's all he has in his closet too. Probably, 50 jackets and 50 sneakers. Just to go back to sort of your experience with your app. He's talking about, agents going to work, and he says, well, here we are. We can program with the English language, is what you showed us.
Yeah.
And he says, this is the prompt: make a JavaScript Newton's cradle animation in a single HTML file. And the output is a nice image of the Newton's cradle with the balls going back and forth hitting each other, getting the physics right. And then another example here is I lost my remote control battery clip. It looks like this. Create a CAD file ready for 3D printing to create a new one. So they've uploaded an image of the remote control battery cover. And there's what it would look like if the 3D printer made one for you. Right? So anybody's going to be able to design, create, program anything they want.
And do you realize how many trillions of matrix multiply operations it took to go from the left side of this to the right side of this?
Isn't it crazy?
Yes.
Yeah. And so there again, the infrastructure that you need for that to happen is pretty crazy. This little diagram here I thought was really instructive. He's showing it's different sort of parts of this process. We've got the LLMs in the middle that deal with the context, observe, reason, and act.
Right.
And then you've got the prompt that comes in.
Right.
You've got the orchestration, which requires CPUs. You've got memory, which is a whole bunch of stuff, including CPU, DPU, and so on. And then tools and skills. And one of the things that Jensen talks about is all of the software tools that have been previously developed actually can be used by AI. Like,
right.
You don't need AI necessarily right now to go out and create a spreadsheet from scratch. It can just use existing spreadsheet software.
Right. Yeah.
Right.
Yeah.
Now, maybe that'll change in the future.
And there's plenty of deeper technical tools chains that can be driven by, again, it's a data thing. For example, one of the things that you might do to my app is you might say to the AI to put it under the profiler, and the profiler allows it to see how it's using the resources of the compute device. That this, in the case iPhone, like memory, disk, is it growing? Like imagine that you have this app running, you want to know, is it like, is it growing disk SSD, right? Is it growing? Like, is your app about to like just take up everybody's, right? So you can put it under a profile, but you could also imagine just asking the AI to, profile it for me, and it knows that there's a tool resident in the Xcode suite that it can use. I mean, for example, even though it's demanding that Xcode do it, behind the scenes, it will write its code. And you notice the last step that we had, it was like doing something. Well, what it was doing is it was compiling the code under the Xcode. It was using Xcode. It wasn't visually using it. It was using it under the hood, the tool, the compiler, and to determine whether it made mistakes in the code. Because it doesn't want to hand it over to me, and then I try to compile it and it's all broken. It rather deliver me a runtime program problem than a compile time. Anyway, yes, you can use tools. You can use a lot of tools that already exist. The AI doesn't have to rewrite those tools or understand all the nuance of what's in those tools.
This next slide, Phil, is Jensen's explanation as to why Elon and SpaceX is going to destroy everybody. Without Jensen saying maybe knowing what he was saying. Well, obviously he knew what he was saying, but without that intention. But this was what I took away from this slide. I think this is actually a pretty amazing slide. This is where Jensen says, the more you buy, the more you make. Right? This is a sales pitch. It's the greatest sales pitch of all time, by the way.
Yeah.
But he's making the case here that compute is revenue. Like you build this compute, you will get more revenue, and this is why those companies that we highlighted earlier a minute ago are spending so much on compute. It's literally going to drive their revenue. But here he's showing some of the factors that help maximize the revenue and profit generation. So the first thing he talks about is TTFI, which is time to first token. So think about Elon with Colossus. The time to the first cluster being turned on was 121 days. With Colossus 2, that accelerated to 91 days, when most other data centers probably would be a couple of years. So this here on the left side, this time to first token, if you can get on this curve on the green line instead of the blue line, you're generating revenue that much faster. Okay. And then you push up here to this top line, and you're looking at efficiency. You're looking at tokens per watt. Well, who do we know that's super focused on efficiency, more so than probably everybody else?
Yeah. Well, especially in terms of free power in.
Yeah. Right.
I mean, in other words, there is the physical efficiency aspect of the chip and its architecture, but then there is where do you get free power in a
the
power
chip side is terafab, and the custom chips that they're making for Tesla and the custom chips they're making for orbital data centers.
Yep.
And then, of course, the power side is the orbital data centers, the solar arrays in space.
Solar arrays in space, unlimited power.
Yeah. And then here, this MTBI, mean time between interrupts. So here you think about maybe there's a whole bunch of factors in this, but one of them certainly would be megapack to provide a consistent source of power. Because if you have any sort of other issues, you might experience an interrupt. And so to the extent you don't have these dips every now and then, that helps. And Elon probably too is also focused on pushing out the curve here on the right side, the useful life side, as well. So to me, this was a beautiful case for the advantages that the Elon and SpaceX and Tesla have.
It's so funny. Every time I see these things, I think about it exactly in those terms, because I think about like one of the things that we see with Elon is like, for example, last week he did this post and he was talking about the deep nuance of like, oh, we're going to use our compute cluster more efficiently by redoing this layer in handcrafted C and assembly code and, blah, blah, blah. And so what's very cool about him running the show for the companies he's running them for is that the material things that matter are deep engineering problems. It's the way very mature engineers think in terms of efficiency most of the time, and not making things that don't require it, not engineering something that doesn't need to be done, right? But then engineering like on the key bottleneck problems. And you think about it as, if you think about it, the way Elon focuses so much of his energy, he always looks at those bottlenecks and he's trying to break those bottlenecks wide open. It's either, it's time to something, time to first byte, time to, and I think he's looking at the compute bottleneck at large, and he's saying, well, I can play around with the scaling laws by taking, like, for example, that post he made about increasing the training performance, really what it was, trying to keep this conversation extremely simple. What he was saying is, okay, we're going to go get, we did all this extra work and we're going to get X back, right? But the problem is and so he goes and he gets his X back, right? The problem is he can't get 2X back after that, or 5X back.
Yeah.
But then if he can throw this whole thing into space, eventually as it replicates itself, that's another whole interesting story, but we won't go there. But if we can just throw enough compute into space, we can get to the point where even the inefficient users of compute, which are more than the efficient users, right? So the efficient, the tokens per watt or all those kinds of guys are really dialed into that. Well, that's really Silicon Valley, and usually they're the producer of tools, the tool chains, these LMs, et cetera, that deliver this kind of reality. But if you look at that, it's far and few between as you start to push this out, and you push this out even further. And if you look at the experience with this thing that I did on my tool, oh my God, you have no idea how much I'm focused on the efficiency of this thing running on your iOS device. That would be insane for somebody that doesn't understand what the even resource utilization on that device looks like, right? So the other side of this argument, and the reason why AI use is going to explode, is because the way the average person uses it is not engineering mindset oriented. They're just going to, my friend up the street doesn't know that digitizing motion is hard. So he comes away thinking, can I just do that? Can I just add that? Well, that's completely rational for him to think that, because that's what he wants it to do, right? But he doesn't realize, oh my God, that is ready to melt the data center kind of hard, or maybe it's not. But so many of the things that people will be asking their AIs to do will be such demand drivers, because they're going to be doing things that are effectively a lot more. How when we have limited resources on anything, we're very cautious about how we use the thing we have, right? We're very cautious. But if the resources just look unlimited, we go off and we use it in, very liberal with our use of the tool, because if we can make mistakes and there's no penalties, or we can try before we buy, or we can do it this way, or we can do it that way. And so that's the thing that AI is doing. It's taking the problem that was crafted by craftsmen, and it's moving it out to the right to anybody's tool. And the people on the far right don't know what the limits of the tool are. So they're going to demand the tools do all sorts of crazy heavy lifting use cases.
That's right.
And because of that, companies these companies have to increase their CapEx to even have enough compute to deliver the tools that are getting used. It certainly, I think people are going to slam in their heads into a brick wall. And when we start seeing companies charge for these things on a more rational basis, look, I've used this tool here, originally I threw down $20 into Cursor AI, and I ran out of tokens. Sometimes the programming step was 200,000 tokens input output in the system, and sometimes it was 3 million. And there's a chart that you can see, like almost like you run a task and see how many tokens it produced. And then I had to upgrade to the $60 version. Ooh, $60. And I'm thinking to myself, I feel like I've used more than $60 worth of GPU time. Like I really do. So and I feel like that stuff is getting more expensive by the minute. And we are not I don't really understand how. Like, I think if I were to meet Elon and I say, what's the one thing I would say to him? I know this sounds stupid to say to Elon. I'd say, please go faster.
Yeah.
Because I feel like the constraints that we're going to run into with the compute side of all these tools, we've enabled so much. And then we're going to see, oh, well, wait a minute, those resources aren't really available to you.
Yes.
You have to pay top dollar for them. That's going to become more real because there's not going to be enough. And then, by the way, that'll change again. When Elon gets scale in space, then all of a sudden it'll drop it'll fall off the cliff. I mean, I'm sure there's someone listening to this going, Phil, don't you understand how economics works? But my point is right now we're in the early cycle of that, and we've been in the free mode, and we're about to hit the heavy constraint mode. And then as we demand more, of course, the supply will open up, and but that supply, but it's got to go through some heavy doors, right? That's the thing about it, right? We're not like doing something linear here. We have to build more than one terafab, and then we have to operationally get Starship to the level where it's doing 3 to 5 launches a day.
Yes.
To launch hundreds of satellites a day into sun-facing orbit so that we can compute the hell out of my friend's biomechanical analysis problem. That's really what it is.
And this is the flag for him. We do this not because it's easy, but because we thought it would be easy.
Yeah. I love it.
And maybe this is the flag that sits behind the Tesla FSD team as well.
Yeah.
It's probably a flag for anybody that's trying to do anything that's new.
The funny thing about this flag, this saying is, there's multiple dimensions to this thing,
Yeah.
It is the thing that so many people put themselves into a place. I mean, maybe it should say with AI, we do this not because it's easy, but because it is easy. But so many engineering problems really end up here, right? Hey, let's go build a company that does, and then when you get into it, you're like, that's a different beast.
That's right. So we have just a quick side note here. We've got Jensen here in the early days where he's got dark hair, and of course we now know Jensen is a little bit different. But I had our AI friend add us standing next to Jensen, and I'm sorry, it's coming back to that image. Oops. Yeah, here it is. So that gave Jensen a very, made a very young version of himself.
Yeah, it's nice.
And I guess we look pretty boyish as well, but I'm dressed up as a CPU and you're dressed up as a GPU.
Oh, well, I'm more compute capable than you are.
Yeah. And the thing around my neck looks a little uncomfortable.
Yeah.
Especially if that fan is
especially if it moves. What did you direct? What did you ask?
I said, basically, it was a very short prompt. I said, add Jensen between the two characters, and on the character on the left, dress him up as a CPU.
Oh, okay. You told.
Yeah. And character on the right, GPU.
Well, we're in good company because we start off with Elon.
Yes.
And then we end up with Jensen. These are two good guys that
we're hanging out with some important folks.
Yeah, we are.
Absolutely.
Yeah.
This is one thing maybe to end on. This is also kind of interesting from his presentation. He's talking about agents, and now they're developing a CPU for agents.
Yep.
They call NVIDIA Vera as part of their Vera Rubin platform. And interestingly, the early adopters are OpenAI, Anthropic, and SpaceX here in the top part of the chart. I posted this on X, and my comment was essentially, Jensen has just told us who the 3 fastest growing companies are going to be in the next few years.
Yeah.
Certainly OpenAI and Anthropic coming to market this year with their own $1 trillion plus IPOs.
Yep.
But SpaceX now should also be thought of in that same category because these are highly scalable businesses.
Yeah. Look, the 3 biggest IPOs in the next year will be
those 3 companies. Yeah.
I mean, Vera really, very much next generation Blackwell type of, really. Look, they're looking for a product here that is data center dense. It's a pretty extraordinary chip. I think the interesting thing is that, where does it go in terms of these people feeding it enough power to get it done?
That's going to be their constraint. They're going to have to look to the company on the right, SpaceX, to help them out.
Yep. I mean, it's the theme. It is literally like I said, if I'm the crazy man walking around my block, I'm like, don't you people see it?
Yeah. And does Sam Altman ever go to Elon and ask for his help, or is Sam Altman forever confined to Earth?
What's really ironic about it? Sam has to go through SpaceX to make OpenAI grow.
Mm-hmm.
He may know it. He may not know it. But that's the truth.
We've seen how quickly relationships change.
By the way, just one other note is the 2 on the left don't build data centers.
Yeah.
The one on the right is building terrestrial-based and space-based data centers. So those 2, they got to go through him. One of them already did.
Yes.
Good friendly deal. The other is sitting out there wondering, where are we going to get our next compute?
And Elon wasn't always so friendly with Anthropic. He used to refer to them as misanthropic.
Yeah.
And take jabs at them all the time on X. Yeah. And so that suddenly, over the course of a weekend seemed to change. And then this deal was announced. So it'd be interesting to see if he can ever bury the hatchet at all with OpenAI, or if that forever is something that he just is not going to be able to get over.
It's hard to say. I mean, I'm very much on Elon's side with regard to that argument.
Mm-hmm.
And I think Sam Altman is a very interesting character that I would never work for.
Right.
But that said, who knows? I mean,
who
knows?
Yeah.
I mean,
anyway,
part of me feels like Anthropic, if it can grow itself from an infrastructure point of view, and like very smart of Anthropic to do that deal with SpaceX, because Elon can easily say, you're in the loop, you're in the pipeline, you're going to my next place, which is space. You've got that e-ticket to go there. If I was them and I had the money, I'd pay the premium too, because I just basically bought myself a future with that. And I think if they can grow, Anthropic can grow at the rate they're growing, I'm not even sure that. Look, it's easy for me. I'd say that Anthropic and SpaceX are amazing companies and you should invest in them, and OpenAI will have an IPO and I don't think you should invest in it. Not because what I think of Sam Altman, but I just think that they're going to get starved out.
Mm-hmm.
And I don't understand how they're going to, even if their teams produce amazing, they better work on their efficiency.
It sounds a bit like Yahoo versus Google back in the old days. Maybe it's not a great analogy, but Yahoo had what looked like a very promising future until they didn't.
Maybe Netscape, Microsoft.
Maybe.
Yeah.
Although Microsoft was a bad actor and SpaceX doesn't behave that way.
Yeah, that's true. I mean, Yeah, Microsoft used its leverage effectively.
Yeah.
But then Netscape sat there and, kind of, you remember back in the day when there was this thing called Apple with Macintosh and Microsoft came along and, and there was this bumper sticker that people had and it said, Windows 95, what the heck would it say? Windows 95 is like Macintosh. What was that sticker? I don't have it coming to my finger. Windows 95 is like Macintosh. Sorry, I'm not going to get it.
Yep.
The point of it was that they were trying to tout the fact that the reality of the situation is that Apple, through Microsoft, had done a really good copy paste of Apple's business through the interface.
Yeah.
But then Apple just sat there and languished. And as a result of that, it moved very slowly. And, and so the Apple game was, well, you're not going to beat them in court. So it was a copyright lawsuit when it should have been a patent lawsuit. They kind of got that screwed up. But the reality is, at the end of the day, you got to out innovate. And you got to, how quick you move, and it's partially innovation, but it's partially what you build and how quickly you build. And our friends over in SpaceX know how to go fast and innovate. So I don't think, who's really going to eat their lunch?
Well, at the pace they're moving, it's hard, even just to keep pace with them, let alone try to catch up if you fall behind. The interesting thing is Elon's trying to play catch up with Grok, and it seems pretty clear to me that at some point he will, and maybe faster than most people realize.
By the way, my brain finally fired and figured out what I was trying to say. Sorry.
Yep.
It was that Windows 95 is like Macintosh 85.
Yes.
So it was trying to take a dig at Microsoft for not innovating.
Yeah.
And yet the reality is the other bumper sticker you could place next to it is, yeah, but Macintosh 95 is like Macintosh 85. 85. Yeah. And so they did not move.
Yeah.
We saw this happen with Netscape. Netscape got pretty happy with itself in the browser to server business, but people always think of it as the browser wars. And yes, Microsoft had an amazing advantage of being able to cook Microsoft Internet Explorer onto all these platforms. But what people forget is that Microsoft also produced Internet Information Server, and Netscape had a really piece of junk for the server side when that was the business that they really wanted to be in, and they produced really kind of a junk product. It's crazy. And so Microsoft not only beat them based on their monopoly basis, but also came around and beat them with a better product. Microsoft doesn't always do that, but it did in that instance.
It did back then. Yeah. Phil, the final thing I think I wanted to get your thoughts on is this slide from Jensen in his presentation. He's now talking about robots, and he's got robot capability on the y-axis, and on the x-axis, compute and data volume. And he's starting with teleop there on the left side, moving to classical sim, moving to internet plus synthetic data, and then the big one is world foundation model.
And you know why I'm smiling? Go ahead. Oh, what am I going to say? What am I going to say?
Please share.
Yeah, like look at that Tesla Vision Tech on the top right there.
Yeah.
Right.
Yeah, maybe just expand on that for people that's not obvious for.
Well, I mean, look, we've come through trying to keep it simple. We've come through this sort of age of AI where we have started, the battle in AI, or the was all about, image processing in the early days, believe it or not.
Mhm.
And then it moved quickly to language when Google had its breakthrough, and OpenAI did its thing. LLMs became people focused on the language side. And the beauty of language is actually it's not very information dense compared to image data, especially if image data is in the form of video, right? Meaning
picture says 1,000 words, tells 1,000 words.
Yeah, kind of indeed. And so, you could, even though that LMs are incredible, there's a lot of data to go in and to produce the model, and the models are big and they require a lot of compute. It's kind of nothing like image processing. Image processing is so much more dense in terms of the foundational data. So if you think about it, the biggest image processor product in the world is FSD from an AI perspective. I mean, probably just in general, it's constantly, and I guess if we did the math, and I'm not here to do it, but I'm saying if we added up all the power consumed for the image processing on FSD, we'd be, I think, shocked. But what is it? It's well distributed into our cars. We don't really think about how much image data we are running through on an inference basis, right? And the training side, but I'm talking about the inference side. So what we get to is the reality is that we're looking for, these world models. These sort of require the idea of looking at the world as we see it in sort of a natural way, and the primary input vector for that is pixels.
Mm-hmm.
Now we might say that isn't really the end extent, but at least from a human perspective, if we as humans walking around planet Earth, most of the data we take in is vision. We're sort of a photon collectors. I mean, we are in a narrow spectrum, right? We aren't seeing the infrared. We're not seeing the ultraviolet.
That's right.
And there's a lot of information there. We don't recognize how much information is really sitting outside our reach. But we've modeled an entire existence. Our world model is based on vision. Mm-hmm. And so in order for AIs to get really good, is they've got to get past this idea that everything written down is what it's all about, because it's not what it's all about.
That's right. That's a very condensed version of reality.
It's a very condensed version, and it's condensed in weird ways. Some of them are biased, and others are, there's all sorts of dimensions to how that data got condensed. But what is written in a book is a small piece of reality about what is really out there, and we know, and so much of our reality, I mean, ultimately we observe, we think, we write about it. We then train an LLM by what's written. And we say, well, if we could only get the data from these experts, if we can only, but these people have gone through their own filters on that data, and they've written down something. And the observable world, the observable world, when I wrote the data chapter for that book that we were involved in, the AI Rising book, I was trying to explain that if we take something like Optimus and we let it go into the world, when it comes about, it will have the ability to observe the world in ways that we barely have scratched the surface, and primarily using the same sensors that we have, meaning like visible spectrum vision data, not all these other parts of the radio electromagnetic spectrum. We're just sort of sitting in the vision space. And when we think about that, we say, well, why? Wait, what can it do better? Well, it can observe on a constant, continuous basis, right? And it obviously then can do a lot of edge compute because it is able to do that. But all I'm really trying to say is, in order to get something that's highly functional in that space, we need to build these world models, right? And get beyond these LLM models. And what's sort of the reality is, it's largely it's all about data. If you have infinite processing resource, you can learn a lot about the world. Especially how we're training these things. But we don't have infinite. We'll get closer to some scale out when we get something like Optimus free roaming. I mean, we don't even. It's extraordinary how limited. Like, we are looking through the tiniest of straw at the world's data. Like, it's like a shard of a. It's like looking through an infinitely small straw, and we're blind to everything. And we're blind over time. We're blind through the type of data we're receiving. So we as humans have built our own world model based on our vision data, but it's extremely limited. And ironically, we've distilled it into written word, which is how these LLMs got their knowledge, right?
It's interesting, isn't it? As I'm listening to you, I'm thinking that, what we call a supercomputer today is tiny compared to the amount of compute that we need. If what you're talking about, is possible over time, the amount of compute that you need is staggering.
It's absolutely staggering. And just as we said, there's so many dimensions to it. We have new classes of users who can demand the compute that we never had before. Back in the 40s, 50s, 60s, 70s, in the early days, there were special people that actually practically wore lab coats that were white, that were computer scientists who had limited access to these timeshare computers, and they were effective experts because the resources were so limited and required so much knowledge to use them in the first place. And then we went through this personal computer revolution. It's why Apple exists as a company, frankly, right? Which sort of then democratized compute to a different level. And when people picked up their first Apple II computers, the first computer Apple made, they were still expert class devices. There were some games you could play, but you weren't really doing much on them if you didn't know programming, and you didn't have a lot of programmers at the, But then they became more information devices, and and I think maybe the next revolution of that was, of course, the mobile device, which, in today's form, like an iPhone, where we're talking about now we've got a whole different class of people able to take digital photos and do all these things that we just, and they're using compute in a different way. But we are sort of now sitting on the precipice of the next massive compute explosion. So your CapEx chart that you had, that flat, that whoever built that shows that flat, that's nuts.
Yeah.
Because life doesn't work that way, especially this life that we already have talked about for 2 hours.
Yeah.
Doesn't work that way.
Right.
It may work in the apple growing business, or I shouldn't have said apple in that case, but, in the fruit laden business.
Yep.
But it's not where we are with compute. We're going to demand so much more of that resource. Yeah. Mm-hmm. What's also super interesting, and I just want to say it, I know we've really run over here, I think, but if you think about the other little side of that SpaceX business called Starlink, just for a small little second.
That small little business called Starlink?
That's little business called Starlink. And I'm just playing off of that because, as this networking geek here, that just showed you a networking geek tool. Starlink is going to revolutionize the way we think about access to compute.
Yeah.
It is the access layer to that compute infrastructure. It is the way we as humans, we will stop thinking about our terrestrial internet services. There was this thing where people said, hey, you know what you could do? You could jump. I mean, like, there's a lot of people in China who have mobile devices that don't have a wire that goes to their house, right? We jumped over.
Yes.
So, oh, well, we're going to put Comcast, coax cable to more people's homes. Well, that's not very scalable, is it? I mean, it's a good moneymaker when you're the monopoly. Mm-hmm. And then we thought, oh, wait a minute, we'll get this 5G or maybe 6G or something like that, from the cell tower 2 miles away, we get data at scale. Wait a minute, guys. No, that's not it. That at scale are the satellites running over our heads. Mm-hmm. And those satellites interconnect the compute layer that will be sitting above them. And so to think about what's going to happen here, where your compute happens, I mean, we're already starting to feel that. Like, when I was using that tool just now, and I did that nice little demo, I hope people realize the AI was not being computed on my box. There were tools running on my box, mm-hmm. but the AI itself, that's out in the cloud.
Somewhere else. Yep.
And guess what? I don't know where it is. Like, I don't know where that data center is. I mean, for all I know, it's in the middle of Idaho. There's a bunch of potatoes there, and maybe there's a data center. I don't know what's going on, where it is. But we're about to, supersize that revolution in compute. We don't know where the compute is. We don't know where the comm is, because we are bathed in it effectively.
Yes.
And it just exists around us. And the only physical tie we'll have to that at some future point is those devices that do it. And those devices will look more like Optimus than they do cell phones.
Crazy world. Can actually manipulate the world, not just be a device that just sits there and looks at you, but something that can actually do something.
Has agency, can manipulate the world.
That's right.
Can decide what it wants to do, what of data it wants to observe that I'm not observing. Yeah, all sorts of cool stuff. Yeah.
Crazy times.
All right.
Phil, that was a great discussion. We covered a lot of ground there, and I feel like we could probably go on for another couple of hours. We'll spare our listeners. Thank you to everybody that stuck with us. And we will figure out a way to stick a link to the app so that you can play with it. Yeah, we will do that. Certainly when this posts on X, we'll have it in the post. And we'll figure out also if we can do that with the YouTube description as well. All right. Thank you, Phil. That was great. Thank you, Cern. Also great.